Weather prediction used to be a form of witchcraft. Then, in the early days of television, it was so inaccurate it was closer to entertainment than science. Today, the daily weather forecast is a source of readily available, reliable, and important information. Those advances are the result of extraordinary efforts by two very distinguished scientists. Their work has had far-reaching consequences for public safety, for agriculture, and for understanding the fragile ecology of our planet. As World War II raged in Europe, weather reconnaissance was critical to the Allies for planning battle strategy. For Joseph Smagorinsky, that meant flying into storms to analyze wind, temperature, humidity, and cloud cover. For Norman Phillips, it meant analyzing atmospheric conditions to determine why the headwinds on flights between the Azores and Bermuda were so strong. It was during this time that Phillips and Smagorinsky met and became lifelong friends, and together changed the face of modern weather prediction. After the war, they joined the legendary mathematician John von Neumann at the Institute for Advanced Study at Princeton, where one of the first large-scale electronic computers had been developed. The theories of general circulation, first proposed more than 100 years ago, had helped explain what caused the wind and jet stream, namely that heating at lower latitudes and cooling at higher latitudes caused differences in pressure that helped mix warm air from equatorial regions with cool air from the polar regions. These theories were developed mainly from balloon observations and later from instruments on board aircraft. The weather maps drawn from these data were then used to predict future weather patterns. Norman Phillips and his colleagues took a radically different approach. Phillips' key insight 50 years ago was recognizing that atmospheric motions obeyed the same laws of physics that governed other motions. Applying Newton's mathematical equations to the atmosphere, Phillips reasoned that if he knew the current state of the weather, he could put that information into equations that could accurately predict future weather patterns. Even though the computer technology of the time was primitive, Phillips was able to write programs that codified these equations. And today, they continue to form the basis of all numerical weather forecasting. At NOAA, the National Oceanographic and Atmospheric Administration, the computer models developed by Phillips were further extended by Joe Smagorinsky. Smagorinsky created a lab to concentrate on short-term weather prediction and forecasting, as well as to analyze long-term atmospheric conditions. It was in Smagorinsky's lab that the first studies were made of global warming resulting from increases in carbon dioxide caused by human activities. Smagorinsky's research team was also one of the first to model El Niño, the disruption of the ocean atmosphere system in the tropical Pacific that can affect weather around the globe. Smagorinsky's work at NOAA not only benefited public safety, but helped determine a long-range approach to weather that has heightened our awareness of global environmental dangers. The 2003 Benjamin Franklin Medal in Earth Science is awarded to Norman Phillips and Joseph Smagorinsky for their major contributions to the development of models of weather and climate, their pioneering studies that led to the first successful predictions of the weather using numerical methods, and their seminal role in establishing the current global observational network for the atmosphere.